All right, chain rule. But let's first back up and do a little quick review here. Consider y equals 7x squared. Then dy dx equals, Jace, what's the derivative of 7x squared? 14x. Easy peasy. But what if we had 7 instead of x squared, 3x plus 1 squared? How would we find dy dx? Without the chain rule, the way we would have to find that is, like, we don't know how to do this, like, inside, like, one function inside another. So the only way we could find this is to FOIL this thing out. So 9x squared plus 6x plus 1, and then distribute the 7, 63x squared plus 42x plus 7. This gets kind of annoying. Then we could take a derivative. Addie, put you on the spot. See if you can multiply big numbers here. What's the derivative of 63x squared?
126x.
Yes. I'll keep going. Yeah, they get easier from here.
Is that just 42?
That'd be plus.
Oh, 42. I was trying to get 42x, but I can't see if there's a.
I knew what you meant. I got you. And then the derivative of 7.
What's the derivative of 7?
Addie, the derivative of 7 is 0. Okay, so I mean that wasn't terrible, but if we had 7 times 3x plus 1 to the 9th, how would we find dy dx? Well, you'd first have to do 7 times 3x plus 1 times 3x plus 1 times 3x plus 1, have 9 times. That's not fun. Fortunately, there's a thing called a chain rule. And the chain rule is for, one way to say it is for like nested functions, one function inside another. The more official way to say it is for composite functions. F of g of x. Basically, you use the chain rule when you have a function with a non-plane x, meaning something other than just an x being raised to a power, like that 3x plus 1 squared. Or with a non-plane x as the argument or the exponent. Like, I guess the hardest part of chain rule is recognizing when to use it, at least initially. After you get going, you'll do it automatically. But for now, do you see parentheses? Or could there be parentheses? And if the answer is yes, then you got a chain rule problem. So here's the connection between the chain rule and blow pops. Sometimes I get Tootsie Roll Pops, sometimes blow pops. Today, blow pops, because that's what the store had. So this sounds dumb, but explain to a 5-year-old the steps of eating a blow pop. What would be the very first step? Take the wrapper off. You don't have to write this down. This is kind of dumb. But it connects to the chain rule. Thank you. So if you take the wrapper off first, then what part of the blow pop do you eat next? The candy outside. I'll put both of those. And then what part do you do last? Eat the inside, the gum, the inside gum, or the gum inside. Good. Now we've reviewed how to properly eat a blow pop. Good job, and you all knew how to do that. The good news is, if we wanted to like summarize this, we work from the outside in, and we do one layer at a time. And that's the chain rule. Work from the outside in, one layer at a time. It's been it's probably 10 years at this point we got to this point in the lesson, I passed out the blow pops, and one student who was, I don't remember his name, but he was sitting where Jay sits. He got his blow pop. He did not remove the wrapper at all. Actually, I think it was a Tootsie Roll Pop because it was paper, so it was more manageable. He just bit into the whole thing, wrapper and all, chewed it up, swallowed it, and was like, I'm done. Are you a psychopath? That's not how you eat a Tootsie Roll Pop. But it served as a great example because the most common mistake on the chain rule is doing what that kid did with his Tootsie Roll Pop. It's I'm just going to eat it all at once. It's delicious. No, that's not how you eat a Tootsie Roll Pop, and that's not how you do the chain roll. You got to go one layer at a time, outside in. Okay? And if I put a note on your, test, no, you just ate the blow pop all at once, you'll know what I'm talking about. That's what that guy did. Okay, so let's look at some cases requiring or using the chain rule. Well, let's see. Let's make sure we covered everything here. Eat the outer part of the pop first, leaving the inner part alone. Then you eat the inner part of the pop. Take the derivative of the outer part first, leaving the inside alone, then multiply. This would be the part that's not the same as eating a blow pop because there's no multiplication when eating a blow pop. But how you connect the steps is with multiplication. And that multiplication connection is the chain part of the chain rule, because you're going to chain the derivatives together with multiplication. That's the link that ties the two together. So, one layer at a time, linked by multiplication. So let's do some. 2 times 3x minus 7 to the 8. Okay, so I see an 8. We'll have to do the power rule. But I also see 3x minus 7, so I'll have to account for that. The 2 is a constant, so it's just kind of going along for a ride. Well, the outermost function is that thing to the 8. So let's bring the 8 down. Decrease the power to a 7. But that's our one step. So we're going to leave the inside alone. That's messing with the wrapper. When we're messing with the wrapper, leave the inside alone. That took care of the outer part. Now we'll chain it with multiplication to take care of the inner part. Color-coded this. So the 8 and the 7, that's the yellow stuff. What's the derivative of 3x minus 7? 3. So there's our chain rule. Maybe the simplest chain rule we could do. We could clean that up a little bit. Don't have much space. 2 times 8 times 3 is 48. 3x minus 7 to the 7th. But I'd almost rather you leave the safe stop, because when you leave the safe stop, you can clearly see the chain rule. When you simplify it, you sort of lose sight of the chains that you piece together. All right, this second example. So I've got to do the derivative of sine, and I need to do the derivative of 5x to the 4th. Okay, the 3 is still there. Which is the outermost candy here, or the outermost thing? Which of the functions, the sine or the 5x to the 4th? The sine. So let's do that derivative. What's the derivative of sine? Cosine. Now that's the first layer, so we don't do the inside stuff. So we leave the 5x to the 4th alone. So there's my outer derivative, and then my inner derivative. What's the derivative of 5x to the 4th? 20x to the 3rd. And I think for both space purposes and concept understanding, I'm going to leave that. I mean, it's an okay safe stop. And again, when you leave it like that, it's clear to see that you've chained the pieces together. On a multiple choice test, they're going to put 60x cubed in front, but then you sort of lost sight of the chaining. All right, why don't you try the next one? So you got a tangent that you'll have to take care of, and a 4x that you'll have to take care of. And you might have to flip back to remind yourself what the derivative of. So there's that chain rule. Sometimes you get a nested chain rule. I mean, they're all nested, but like multiple chains. The chain of the chain of the chain. So the 2 is just going along for the ride. I think I see 3 different things going on in this last one. I see a secant, I see a power of 5, and I see 3x to the 8. Which one of those things is the outermost thing? The power, well, which power rule, I guess? The 5. So the derivative of, you know what, I'm going to have to put this on a separate line because there's so many chains together here. The derivative of something to the 5th is 5 times the thing to the 4th. But the stuff in the parentheses doesn't change, right? Because we only eat one layer at a time. So in parentheses is secant of 3x to the 8th. What layer do you want to pick off next? What's the next layer in? The secant. And the derivative of secant is secant tangent. Be careful though, we still want to leave the inside alone. So secant of 3x to the 8th, tangent of 3x to the 8th. And then lastly, the derivative of 3x to the 8th is 24x to the 7th. So that was a 3 chain rule. Some more practice. Why don't you try 1, 2, and 3. I think those are simple enough, and straightforward enough, and similar enough to say try those 3. Do you know why that answer is not quite correct? I corrected one person on it. Parentheses. Because right now you'd only be multiplying this stuff by 4x cubed. You really want to multiply by all of it. And I had been using like highlighters, but that's not enough to show that you want to multiply by all of it. So that stuff would need to be in parentheses. Number 2, find the instantaneous rate of change. Well, again, that's another name for y prime. So 9 times 4 stuff cubed. And don't mess with the stuff, right? One derivative at a time, one layer at a time. 2x to the 7th plus 5th plus 5, and then times 14x to the 6th. Again, multiple choice is going to clean this stuff up, but for now I like leaving it written out because you can see the chains pieced together. Slope of the tangent line, again another word for derivative. 33 times 3 is 99. All of that to the 32nd. And then the derivative of the inside stuff would be 3x squared minus 1. And again, I've intentionally missed something there. The parentheses. All right, it's going to be a bummer to make a 99 on the test because you left off the parentheses. What makes number 4 different? Add a value. So we'll take the derivative and then just plug in 2. So derivative of sine is cosine. And derivative of 4x is 4. I'm going to move the 4 to the front because it looks weird at the end. So this 4 is coming to the front. Cosine of 4 times 2. And that's a safe stop. Especially since I don't know what the cosine of 8 is. I can just leave that. Either one of those is an okay answer. skip 5. 6, I think, is fairly straightforward. Is it straightforward enough for me to just pick on somebody and see if Brooke can tell me what the derivative of number 6 is? Put her on the spot. What's the outermost function, Brooke? The 6. It's not necessary, but sometimes it's helpful to at least think of it like this. Right? When the 6 is put right there, sometimes you get confused on who's the outermost. But what that means is take cosine of x and raise it to the 6th. So now, Brooke, does that make this problem a little bit easier to look at it like that? Okay, so now what's my answer? That's what you said. Did you leave something out when you were reading me back the answer?
Also
the 5. So cosine of x to the 5th, and you can write it either way. You can put it in parentheses with a 5, or you can be fancy and put the 5 right there. Either way is okay. The multiple choice is probably going to put the 5 there. It's also likely to put the negative in the front. Negative 6 cosine x to the 5th times sine of x. Again, nothing wrong with this answer, but that... No, that would be okay. Like any equivalent answer is acceptable in calculus. But the parentheses up here on number 1 and number 3, that's not just making it look nice. Like if those parentheses aren't there, that means something different. So those parentheses have to be there. What's number 7 asking for? Second derivative. Well, there's no magic way to get to the second derivative. You just have to take the first derivative and then take another derivative. So the derivative of tangent, Johnny, do you remember the derivative of tangent? Secant squared. So secant squared of x. And now maybe we see why this is in the chain rule examples, because it didn't take a chain rule for derivative of tangent, but with secant squared, bring the 2 down, reduce the power by 1. Oh, this one's going to end up looking kind of funny. What's the derivative of secant? Secant of x, tangent of x. Now, again, that's a perfectly acceptable safe stop answer, and I would encourage you to leave it like that if you can, because you can see the chains there. But multiple choice, 16, and then secant times secant is secant squared. That's going to be the multiple choice answer. Kind of lost sight of the chain when the two secants get multiplied together. Number 8 is another multiple chain thing. So you try number 8. Let's skip number 9. It's just another 3 chain problem. Look at number 10. Remember what you would do first on number 10? We don't know how to do the derivatives of square roots. So we need to put it all to the 1/2. Because we can handle a power of 1/2, we can't handle a square root. Okay, so now it's relatively forward chain rule problem, as long as you can do 1/2 minus 1. Justin, what's 1/2 minus 1?
It's a negative 1/2.
It is negative 1/2. Again, don't mess with the inside, like one step at a time here. And then let's see, that would be 8x cubed plus 3. But I need to multiply by all of that, so I need to put it in parentheses. Perfectly acceptable answer. Multiple choice test might, let's say there's a 2 in the bottom, and they might even put it back as a square root. Real fancy. Again, I wouldn't do that, because you'll sort of lose sight of the chain thing, but that's what a multiple choice answer might look like. I think you can get, do the algebra from one to the other. What about number 11? What's that going to require? Sort of 2 answers for that. Let's rewrite it to the power of 1/2. So what rule is that going to require? There's 2 answers to that question. The quotient rule, and then the chain rule for doing the bottom part. So this is definitely one where I would split this up, and let's find the derivative of the top, derivative of the bottom separately, and then put it all together for the chain rule. Top derivative is easy. And bottom derivative, 1/2 2x minus 2 to the negative 1/2 times 2. See where those pieces came from? I think I would clean that up before going to the quotient rule, just because I can. I don't want it to be too messy. So the 2 and the 1/2 would cancel. I'm going to rewrite this as 1 over the square root of 2x minus 2. Okay, now I'm ready to think back to the quotient rule. So gf prime minus fg prime. Gf prime. That would be this one. Do I want to write it as a square root or a 1/2? It doesn't really matter. Square root 2x minus 2 times 1 minus the other way around, fg prime would be x over square root 2x minus 2 over g squared. So if I square the bottom, I finally get a small favor out of this problem. I just get 2x minus 2. That's an okay answer, but there's algebra to be done to make it match what the multiple choice would probably be. I would multiply the top and bottom by the square root of 2x minus 2. Oh, I do have to plug in the 3? So you're right, it might be better to plug in the 3 before doing algebra stuff. So, good call. Let's plug in the 3 first. Especially since that's going to make things a little easier. 2 times 3 is 6, minus 2 is 4, square root of 4 is 2, minus 3 over 2, all over, yeah, there we go, over 6 minus 2 is 4. So there's a little bit of algebra still to go, but it's easier algebra now. I would multiply the top and bottom by 2, although 1/2 divided by 4 is 1/8, but however you want to do it. So 4 minus 3 is 1, 4 times 2 is 8. So all of that to get 1/8. Yeah, good catch on plugging in 3 before we did the algebra. That made life a little easier. Okay, So assignment today would be the next worksheet in the packet, which is the chain rule worksheet. Now, it's kind of a quick turnaround, so tomorrow I'll answer chain rule questions as well as work some of the review. So my suggestion would be, let's see, today is Tuesday, would be worksheet 6 and some of worksheet 7 so that you'll know what questions to ask. And then Wednesday, maybe do the evens as your review, and then Thursday, Friday we'll test. Now, that's up to you how you split it up. If you got a super busy day today, well then maybe worksheet 7 gets put off. I don't know, do it however you want, but I would try to get the sum of worksheet 7 today so that tomorrow you'll have questions to ask. Worksheet 7 being the review.